Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be continuing our discussion of Section 1 from Chapter 2, and this time we're going to be talking about writing the equations in slope-intercept form. So just so we recall, slope-intercept form is the equations y equals mx plus b, where m represents the slope of the equation, and b represents the y-intercept of the equation. So keeping that in mind, we're going to use y equals mx plus b to write equations of a line. So when you write the equation of a line, there are certain steps that you want to follow to ensure you write the correct equation of a line in slope-intercept form. The first step is to identify the y-intercept of the line. The y-intercept is the location where it crosses the y-axis. So we're going to look on that vertical axis and see at what point is the line touching that axis. The second step is, after you've identified the y-intercept, to identify the slope of the line. So we're going to pick any 2 points on that line and we're going to count the slope, which is rise over run. Once we know the y-intercept and the slope, we're going to plug those 2 numbers into the equation y equals mx plus b. So let's see how this is done. So our first example says write the equation of the line in slope-intercept form. So for this one, we are given a graph of a line, and we need to identify the y-intercept, and we need to identify the slope of the line. So your y-intercept is found by looking at the y-axis and seeing where does the line cross the y-axis. So if we look at the vertical axis, right here would be the point where that line touched the y-axis, which is the point 0, 1, according to the picture, because right here it says that's 0, 1. Now, for the slope, we need to then count the rise over the run. So slope again, rise over run. So what I need to do is, from any 2 points on the line, I need to count the rise and the run. So we're going to use this point here at 0, 1. And we're going to use this point here at 4, negative 2, and we're going to count the rise and the run. So, to rise, I go 1, 2, 3 units down. So that would be negative 3 because I'm going down the y-axis. From the y-axis, I then go 1, 2, 3, 4 units to the right. So I'm running positive 4. So this tells me that my slope of this line is negative 3/4. So once you identify the y-intercept and the slope, we're then going to take those numbers and we are just going to plug it into the equation y equals mx plus b, our slope-intercept form. So y equals doesn't change. M was negative 3/4. The x stays. And the y-intercept was positive 1. So I'm going to write plus 1. So our equation of this line, y equals negative 3/4 x plus 1. Our second example is to write the equation of the line in slope-intercept form given a different graph. So the first thing that you want to do when you are to write the equation of a line is we want to figure out what the y-intercept is. So we're going to figure out the y-intercept by looking at the y-axis and seeing where does our line cross. Well, right here would be the point where the y crosses. So if we take a look, This is 2 units down from the origin. So this is the point 0, -2. Once you know the y-intercept, then you want to count your slope. So to count your slope, slope again is rise over run. So we want to pick any 2 points on this line and count the rise over run between them. So I'm going to use my y-intercept, and I'm going to use this other distinct point on the x-axis, and I'm going to count how much did I rise and how much did I run. So we go up 1, 2 units, so that would be 2 units we rise. And then I run to the right 1, 2, 3 units. So the slope of this line is 2/3. So once you know the slope of the line and the y-intercept, we just plug those numbers into y equals mx plus b, the slope-intercept form. So y equals, m was 2/3, the x will stay in the equation, and then the y-intercept was -2. So we're going to write -2. So our equation of the line, y equals 2/3 x minus 2. Our next two examples are going to require us to write the equation of a line just by being given 2 points on the line, not given the graph like we were in previous examples. So we have to use something special called the slope formula in order to write the equation of the line. So we already know that slope is equal to rise over run. And if we think about when we rise, we're going up and down on the graph. That's changing our y values. Whereas when we run on the graph, we're going left or right. That changes the x values. So when we do slope, what we're going to have to do is figure out what's changing in our y values over what's changing in our x values. So we're going to use the slope formula. Slope is rise over run in order to find the slope between 2 points and then figure out the equation of the line without graphing. Our first example of writing the equation of a line given 2 points without the graph says write the equation of a line in slope-intercept form passing through the points 0, -2, and 3, 4. So when you're not given a graph and you have to write the equation of the line, you must use your 2 points to figure out the slope of the line and the y-intercept of the line. So we're first going to figure out the slope of our line, which remember is rise over run. Now remember, when we rise, we are going up and down on our graph, which means our y values are changing. Whereas when we run, we're going left and right on our graph, which means the x values are changing. So when I calculate slope, I need to essentially figure out the difference in the y values over the difference in the x values. So what I'm going to do is I'm going to first narrow in on my y values in the 2 given points. So my y value is always the second number in a point because points are written x comma y. So what I'm going to do from left to right, I'm going to subtract the 2 numbers that I just underlined. And I'm going to say -2 minus 4. Once I've figured out my y values, I then must repeat this process with my x values. So I'm going to identify my x values in each point, which would be the first number in each point because points are written x, y. And then again, going in the same order, left to right, I'm going to subtract 0 minus 3. Once I've written down what I'm going to subtract, I then actually have to do the math. Negative 2 minus 4 is negative 6. And 0 minus 3 is negative 3. You then always want to simplify your slope if possible. So 2 negatives make a positive, and 6 divided by 3 is 2. So my slope of this line is 2. So once you figured out the slope of the line, you also need the y-intercept to write the equation. Now, before we use a long, drawn-out process to find the y-intercept, you always want to look to see if one of the points given matches our description of a y-intercept. So our description of a y-intercept is that the y-intercept takes the form of a point 0, some number. If we look at both of our points, do any of our points look like 0, some number? If you said this first point, 0, negative 2, you would be correct. So our y-intercept of this line is at the point 0, negative 2. And that came straight from reading the problem. So once you have your slope and you have your y-intercept, we then use the slope-intercept formula, y equals mx plus b, to write the equation of the line by plugging in our slope and our y-intercept for m and b. So our slope is 2, so we're going to write y equals 2x, and then our y-intercept was negative 2, so we're going to write minus 2. So our final answer, the equation of this line in slope-intercept form, y equals 2x minus 2. Our second example says write the equation of a line in slope-intercept form passing through the points 4, 5, and 6, negative 1. So we're going to begin by figuring out the slope of our line, which remember is our rise over our run. Now again, when you rise on a graph, you're going up and down on the graph, so that changes your y values. Whereas when you run on a graph, you're going left and right, which would change your x values. So when we calculate slope, we have to figure out the difference in y over the difference in x. So we first look at how y is changing. So given my 2 points, 4, 5, and 6, negative 1, I'm going to underline my y values, which would be the second number in each point because points are written x, y. And then I'm going to subtract those two numbers from left to right. So we're going to have 5 minus the negative 1. Don't forget to write minus a negative. If you just put 1 minus, then you lost the negative that was with the 1. And once you have your y values, then you want to divide that by your x values being subtracted. So our x values would be the first number at each point because points are written x, y, and we're going to subtract them the same order from left to right, just like we did with the y values. So this would be 4 minus 6. Once you figure out your y values and your x values, you then need to actually perform the math. So 5 minus a negative. Well, 2 negatives make a positive, so 5 plus 1 is 6, and 4 minus 6 is negative 2. Do simplify your fractions if they can simplify, which this one can because 2 goes into 6 3 times, and a positive divided by a negative is negative. So our slope of this line would be negative 3. And that's one key piece of information that we need to write our equation of a line. The second key piece of information that we need to write our equation is the y-intercept. So remember, the y-intercept is a point where x is 0 and y is some number, the number where we cross the y-axis. So we first want to check our points and see if any of our points started with 0. Neither of them did, so we're going to have to use an alternative process to figure out our y-intercept. So that alternative process is going to come from the slope-intercept form of an equation. Y equals mx plus b. So what we need to do, we need to figure out what b is. So we're going to plug in a number for y, m, and x and solve an equation to figure out b, the y-intercept of our line. So we already know m is -3 because that's our slope, but now we need to plug in something for y and x. So we have points that have an x and a y value. We're going to pick either point from the original problem. I'm going to use the point 4, 5 because I like positive numbers, and we're going to plug 4 in for x and 5 in for y. And we're going to solve this equation to figure out what b is. So when I do this, I'm going to replace y with 5. I'm going to replace m with -3. And that's going to be multiplied by 4 because that's what's in the x location of the point. I'm putting parentheses because m and x are being multiplied. And I'm going to drop down plus b. And we're going to solve this equation. So, -3 times 4, that's -12. Drop down plus b. And then I need to add 12 to both sides to get b by itself. So my y-intercept is at the number 17. So once you have your y-intercept and you have your slope, then you can write the final equation of the line. So our final equation of the line will take the form y equals mx plus b. And we're going to plug in what we have for m, our slope, and what we have for b, our y-intercept. So this equation of the line, y equals -3x, and then it's a positive 17, so plus 17. So our equation of the line, y equals -3x plus 17. This concludes our lesson on being able to write the equation of a line from a graph or given 2 points. If you have any questions, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.